Hello, good evening, everybody. Welcome to the live session on our course, Advanced Topics in Science and Technology of Concrete. So I'd be happy to answer any questions you have about this course, about the contents of this course or anything related to it. I'll first try and go into the questions shared in the spreadsheet. Okay, I'm not able to access it. Haripan, can you share the questions with on the spreadsheet? Am I audible? One of the participants is saying that they cannot hear.
Audible, sir.
I didn't get the response. Am I audible?
Yes, sir. Audible, sir.
Okay. Very good. Good. Okay. So can we, all you people have joined. Can I hear from you about the questions? Meanwhile, I request Haripan, our TA, to share the questions that have been shared on the spreadsheet. No one has any questions about the course? Haripan, are you there?
Yes, sir.
Yeah, can you
I'm
share?
audible, sir.
Yeah.
Sir, I'm unable to share. I'll take little
Sorry?
time. Can I take 2 minutes?
Okay, at least those who are online, can you ask any questions that you may have about the course?
Sir, good evening, sir.
Good evening.
Sir, basically we are using this recycle aggregate.
Yeah.
At that time, sir, when we are using this recycle aggregate, are we planning like the concrete strength like M30, M35, M40? Do we go for design of that type of design mix also, sir?
Yeah, absolutely. I mean, we are going to be using it in regular concrete only. So all the normal processes of concrete mixture design will be the same. You're simply going to be replacing conventional aggregate by recycled aggregate. And as per our IS 383, currently you are allowed up to a certain percentage. In plain concrete, you're allowed a certain level. Reinforced concrete up to M25, you're allowed 20% replacement. So you are expected to produce concrete of the same strength grades that you do with conventional aggregate. So, of course, currently the code is rather conservative, but there is definitely an opportunity to increase the amount of recycled concrete or recycled aggregate use in concrete.
Sir.
Any other questions? To the NPTEL staff, can you share the spreadsheet? I'm not able to open it, unfortunately. Any other questions you have about the content? I mean, you've been through the lectures already. I think 4 weeks of lectures were there in different topics. So if you have specific questions about the content, any doubts, because I think your examination will happen in April. Okay, Vishaka has a question. How critical is it to use recycled aggregate for underwater construction? Now, again, please remember, we are only talking about regular construction. I mean, whether it's underwater or overground, it's all about concrete construction. So recycled aggregate can be used instead of, uh, sorry, recycled aggregate can be used instead of normal aggregate, provided you've established using your mixed design strategies the kind of properties that are required. So in underwater construction, one of the major properties that you want obviously is to protect the concrete from getting washed out by the surrounding water. It has to maintain its consistency and not get washed out. So that is one aspect that you need to worry about in underwater construction. But that is more related to the design of the cement paste and the viscosity modification of the concrete itself. You don't really have to worry about whether your aggregate is recycled or normal or natural. So that's not really going to make such a big difference. Okay, NPTEL office, what you have shared here as the link, again, it tells me that I need some sort of a access. I need a code for access. Unfortunately, I don't have that. Can you open the sheet and just put the questions here in the text chat box?
Sir, sorry to interrupt. I
Yeah.
don't see any questions on
Oh, there are no questions, huh? Okay. Okay, then I have to rely only on the questions that people are asking
the
here.
sheet actually. Yes, sir.
Sorry?
There are no questions on sheet, sir.
Okay, that's fine. Okay, in which case it looks like the people online also don't seem to have questions. Matched grading of RCA. Can you please explain yourself? What do you mean? Sorry, I'm unable to hear you. Nirmalidu? I presume we're talking about the grading of the aggregate itself. So I presume with RCA also you have to satisfy the norms for grading as per IS 383. I mean, you need to ensure that you are meeting the norms. So you need to crush your aggregate appropriately and ensure that you are providing aggregates in the correct size ranges. Because the aggregate gradations have been prescribed with a view of increasing the level of packing that you get from these aggregates inside the concrete. I'm not sure if you're speaking, Nirmalito. I can't hear you at all. Okay. Divya has asked, how does moisture condition? I'm not sure. What do you mean? How does moisture condition affect RCA is the question? Because please remember, when you talk about recycled concrete aggregate, there's some mortar or paste that is stuck to the aggregate that is going to absorb moisture, right? So you have to be particularly aware of what the extent of absorption is going to be. And when recycled aggregate is having excess moisture beyond the level of absorption, then you have to also account for that in the mix design process. But again, I mean, that's what you do with normal aggregate also. So moisture absorption of recycled concrete aggregate will be more than normal aggregate. But the kind of strategies that you adopt with normal aggregate construction is same thing you do with recycled aggregate also. So one thing you can do probably to ensure that the aggregate does not start absorbing from the free water in the mix is that you can either compensate for the water absorption by adding extra water, or sometimes people also attempt to actually use the recycled aggregate in a wet in a saturated surface dry condition. That means the aggregate is pre-wetted before mixing it in concrete. What about contamination within recycled aggregate? Absolutely, that's a very major concern because, again, in a typical construction site, when you're actually doing the demolition, or typical building demolition, you're actually going to get a number of different things together. You're not just going to extract the concrete separately and the ceramics separately and all that. It all comes in a mixed condition. Contamination will happen in recycled aggregate. When you're crushing also, it can happen. You can probably crush other material that comes along with it. So again, when you are actually doing collection of recycled aggregate, one important aspect is to look at how best you can do a selective demolition so that you can get the concrete part separated out from everything else. But still, there'll be some level of contamination. You can't avoid that. Yeah, there's a question, can RCA be used for roller compacted concrete for pavement construction? Yes, absolutely. Again, in roller compacted concrete, the idea is to produce a very harsh or stiff concrete with zero slump, which needs to be compacted by rollers. Definitely, recycled concrete aggregate is viable solution there. In fact, at IIT Madras, we have done some research on this also. My colleague, Professor Surinder Singh, works on this topic. And we have actually produced roller compacted concrete with RCA. Again, the processing required for RCA in that condition also needs to be looked at, because if you just simply use direct crushed RCA, there'll still be a lot of weak pieces of the mortar or paste stuck to the aggregate. So to some extent, it may affect the kind of densities that you get with your roller compaction. But yeah, I mean, that's a subject that definitely makes sense to use. Pratik has again asked, are there contaminations, are there any chances of it being reactive? Now, that depends on the kind of contamination that you have. If it is from amorphous organic materials like ashes and all that, obviously some reactivity will be there. But other than that, I don't expect there to be any reactivity from ceramics and other kind of wastes that you get.
Sir, good evening, sir.
Yeah.
Now, sir, once we have collected this RCA through various process of cleaning and from the different methodology of taking away the contamination and everything.
Yeah.
After that, sir, once we are putting it into the mix design and preparing the mix design, at that time also there will be a lot of abrasion between these particles.
Correct.
So what we have initially designed that this much replacement will be required, won't that change in later part once it is being really put into the machine and when we are doing that mix design, sir?
Yeah. See, again, for that, you need to do the abrasion test on the recycled aggregate material also, because that will give you an idea whether when you actually put it in the mixer, will there be a loss in the material? Will it break down into smaller pieces or not? So that idea you need to get prior to actually utilizing it in concrete. So you have to actually do the kind of test that you do with normal aggregate. You should do with recycled aggregate also.
Okay, sir.
Yeah. Another question from Pratik. Recycled aggregates generally more irregular shape than natural aggregates. How do we solve this problem? I don't think it's a problem really, unless you start getting flaky or flat. I mean, flaky or elongated aggregate. If you have a good crushing system, you should not have this problem. You will get aggregates that are more equidimensional. Irregularity is not an issue, only when flakiness or elongation happens because of the improper use of or use of improper type of crushers. If you use jaw crushers and all, you may actually end up with things like that. You may want to use different stages of crushing, even the manufacture of recycled concrete aggregate. We've seen that the impact crushers produce much better results in terms of performance. Again, yeah, economy is something that you need to consider. See, once again, economy will come in even where you have to make a decision between using natural aggregate, which is available, and recycled aggregates, which needs to be crushed and then brought to your site and maybe processed to some extent and so on. So that question of economy obviously will come in anywhere when you want to use recycled aggregate. But we will come to a condition where the use of recycled aggregate may be mandated by the policies. Like in Singapore, they say that every concrete that you make has to have at least 20% recycled aggregate. When that becomes the norm, obviously one has to start looking at what would be the right methodology to incorporate recycled aggregates without compromising the concrete quality. And that's when the cost really does not become a matter of concern, because you have to use, so you better make it in the right way and use it, right? Yeah. Can we produce RA on demolition site by crushing and segregating at various sizes? Absolutely. That's what you need to do. Demolition site needs to have some sort of sorting also to avoid too much contamination. And at the same time, there should be crushing and segregation into various sizes. So when recycled aggregate is crushed, typically we expect to get some coarse, some fine aggregate, and also some very fine material, which we call as recycled concrete fines, RCF. And that has, again, potential utilization as a cement replacement material.
Hello, sir. Good evening.
Good evening.
Sir, actually, as we know, the recycled concrete aggregate has a multiple number of ITZ.
Yeah.
So, suppose one aggregate, recycled aggregate, which we have considered for the use, belongs to a high strength concrete, and we have make a new concrete which is of lower strength using recycled aggregate.
Yeah.
So then, so how can we identify among through which ITZ the crack is propagating after testing?
No, see, if you're making a normal strength concrete, right, it'll have an ITZ with the high strength concrete aggregate, RA. Right?
Yes, sir.
Yeah. Now,
yes, sir.
The original ITZ in the high strength concrete between the paste and the aggregate would automatically be very strong because of the high strength nature of that concrete. That's how you make high strength concrete, right? You increase the strength of the paste, and that also improves the bonding with the aggregate. So you end up with a much higher, much better interfacial transition zone. So
yes, sir.
the likely chances of cracking here would be still between the interface of the new concrete and the recycled aggregate rather than within the recycled aggregate. So it all depends on the relative strengths of the aggregate that have been produced by crushing concrete and the design of the new concrete. Yeah. But again, see, this is something which is not that easy to predict. At what stage does the aggregate start crushing? At what stage does the mortar attached to the aggregate start crushing? Again, that may also depend on, at the time of crushing the aggregate itself, we are also introducing some defect in the aggregate. So it's not always guaranteed that the failure will be at the interface of the new concrete and the recycled high strength aggregate. It could still be in the inside of the high strength aggregate because while crushing, we may be creating some defects in it. So you have to look at it in the entirety. But again, that's more of a matter of research and not really, I don't think it's practically very significant to look at that separately. Pratik has asked what could be
Is there any
restrictions?
specific technique?
Yeah, go ahead. Sorry.
Sir, is there any specific technique? Sir, is there any specific technique or approach so that we can identify through which ITZ it is going? Is there any method or method for that?
I mean, there is no specific technique. I mean, because unless you do a microscopic analysis, you'll not know where the failure has appeared. In any case, after cracking, it's very difficult to do a clear crack mapping as to how the crack has appeared and so on. I mean, if you're really interested in this subject, there is obviously the possibility of doing tomography. Tomography can help you understand what is actually going on. But again, that's too complicated and too expensive a technique to apply to a problem which may not be that significant to really demonstrate. You expect that this problem will happen, but I don't know if it's really significant to demonstrate it in actual research. But yeah, otherwise,
Okay.
I would suggest tomography would be the right technique to go ahead and do it.
Okay. Thank you.
Yeah, Pratik has asked restrictions on doing process on site. Obviously, one restriction would be the environmental regulations. So the demolition site should be located where the handling of the dust is possible and so on. So all of that, you're making a model to crush and separate in small scale sites to decrease the cost. Yeah, because that will increase the possibility of improved logistics. Because if it's available in number of locations, it could be a good idea. But then if you're in cities, then you need to also look at the pollution regulations and things like that. Because otherwise, all these processes of segregating various sizes, the extent of dust that gets created will be significant. Okay, I guess there are no more questions in this course. So yeah, thank you all for attending. We'll wind up. If you have any questions, you can also interact on the forum. Haripan is trying his best to answer any questions that you may have. And if there's something that he needs my input on, I've always tried to contribute. So yeah, I think we can close NPTEL team. Thank you. Thank you all. Thanks, everyone.